Hello students, welcome to a new audiovisual tutorial on operators in C language. We start with a classification of the operators in C language. The first category of operators is what is known as arithmetic operators. This is the most common type of operators that you come across in C. Then you'd come across what are known as assignment operators. Followed by relational operators, followed by logical operators, and then you have something called bitwise operators, followed by something known as conditional or ternary operators. Don't get afraid to hear the difficult term I just used. We'll come to it later on. And finally, we have what are known as special operators. So, this is the classification of different types of operators that we encounter in C language. Fine. Now we take up these operators one by one. As I just mentioned, the first type of operators is the arithmetic operators. As before, we will be taking the help of the PDF tutorials which we already have come across. The name of the tutorial that I'll be using in this case is, let me circle it for you, essentialc.pdf. Now you can have access to them by following the links in my web page where these audiovisual tutorials are embedded or linked from. So let's continue. The first type of operators in C is arithmetic operators, and under its purview we have all these operators. So addition, subtraction, division, multiplication, remainder are also known as the modulo operator. For example, in C you can have a statement which has something like x plus y. That means plus is an operator in C and the operands are x and y. Now since there are two operands, this plus or the addition operator is called a binary operator. So later on we'd come across unary operators where the operand acts upon only a single operand. And you can also have a ternary operator, so there may be three operands. So we'll discuss them later. Now these are very simple operators. I won't go into the details except the last one, the remainder operator. Now suppose in C you are performing a division like this, 6 by 4. Now 6 by 4, 6 is also an integer, 4 is also an integer, so basically this results in 1 in C. So when you divide an integer by an integer, the fractional part is truncated and you get an integer which is left. So if you divide 3 by say 2, of course you'd also get 1. Now what the modulo operator does is, when you perform 6 modulo 4, this will give you 2. That means it gives you the remainder of the integer division. Now in this context, one needs to keep in mind that when you perform say 6 by 4.0, then the result would be the actual value given by the integer as well as the fractional value. The same holds true for 6.0 by 4. And of course, if you use 6.0 by 4.0, that also will give you the actual value. That means consisting of both the integral and the fractional parts. That means at least the numerator or the denominator or both should be expressed as real numbers or decimal numbers so that you get the true value. If both of them happen to be integers, as has been shown over here, then the fractional part is omitted and you only get the truncated integral part. And in that case, if you want to find the remainder of the integer division, you need to use what is known as the modulo operator. Okay. So if you remember, the next type of operator we will be discussing is the assignment operator. Now in C, the different types of assignment operators, among them the most common one is the one which looks like equality, but actually it's not an equality operator, but is rather an assignment operator. So let me see why we have this in this tutorial. I think at the very end, yeah, here we are. So in C, you have not only the most common operator, which happens to be the assignment operator. Let me highlight it for you, this one. So that means when you write x is equal to 2 in a C statement, of course I'm not writing the whole statement, I'm just writing the main important part. X is a variable to which you have assigned the value of 2. That means the value of 2 goes into x. So in C parlance, if I may use the word, we assign the value of 2 to the variable x, and this symbol, the equality sign over here, is not the equality operator in C, but is known as the assignment operator. Now apart from this assignment operator, you also have other types of assignment operators in C, like say plus is equal to, minus is equal to, star is equal to, divide is equal to, modulo equal to. Then So these operators are also assignment operators. How? So let me take one. Suppose you write x plus is equal to 3 in a C statement. What this means is x is equal to x plus 3. So basically they mean one and the same, but as you can see, it's a shorter way of expressing the same thing. So these are known as the assignment operators. So far, the operators that we have been discussing were binary operators. Next, we come across an assignment operator which is unary in nature. That means it only has one operand. The name of this operator is increment operator, and it also has its sibling, which is a decrement operator. So let me introduce you to them. Plus plus, one after another. This is what is known as the increment operator, and minus minus, one after another, is what is known as the decrement operator. Now these unary increment and decrement operators come in two variants. One is if you use plus plus after the variable, and another is if you use plus plus before the variable. So this is known as the post variant, and this is known as the pre-variant. You can similarly have pre and post variant for the decrement operators. So if you have the decrement operator after the variable, it is known as the post variant, this one. And if you have the decrement operator before the variable, it is known as the pre-variant. Now this is something a little difficult to comprehend, so why not we take the help of a program to understand the actual utility or use of these unary increment and decrement operators. For that, let us take the help of a program which I have already written for you. So as you can see, in this program I have initialized, rather first declared two variables I and j of integer data type or int data type, and I have at the outset assigned values or initialized the variables with the values 5 and 5 respectively. In fact, both of them are initially 5. Now in this printf statement, the first printf statement, by now you already know the importance of these placeholders %d, because in their place the value of these two variables are printed. Now instead of specifying just a variable over here, we have in fact used an expression. Now I++, as I just let me change the color and make it somewhat deep. Okay, now I++, what does this mean? Now this is I is equal to I plus 1, and plus plus j, what does this mean? Well, this also means j is equal to j plus 1. So these our shorthand way of writing these two expressions. So basically incrementing I plus plus, and plus plus j is incrementing j. But there is a subtle difference. What is that? As we can see, I plus plus is the post variation and this is the pre-variation. So what is the implication of this? The implication is that when this statement, this first print statement is executed, what you see on the screen is the value of I before it is being incremented by 1. That means here you will see the value of 5. Why? Because here this represents a post increment unary operator, this plus plus. That means first the value of I would get printed over here and then the value of I would be incremented. On the other hand, the value of j, which is printed in the place of this placeholder, is not this 5. Why? Because here plus plus j, this plus plus is the pre-increment. This was the post-increment, the pre-increment. That means this pre-increment operator helps in incrementing the value of j before it is printed in the place of this placeholder. So instead of 5 being printed over here, 5 is first, the value of j, which is 5, is first decremented by 1, first incremented by 1. That means it becomes 6, and then that value of 6 is printed in the place of this placeholder. So what you should expect is, or rather what we should expect is, when this printf statement is executed, what we should see in this on screen is I is equal to 5, j is equal to 6. Now as I said, after these values are printed or put in the place of these placeholders, then this value of I had already been incremented. So no, this value of I was not incremented before. The value prior to increment was printed over here, but now after the value is printed, the value of I is incremented. And then if you use another printf statement, then in this printf statement, the value of I that will be printed over here is the one that is incremented after the value of I that is printed over here. That means previously the value of I was 5, which was printed over here, then it got incremented and this value of I would be printed over here. That means the incremented value would be 6. So here you would expect to see I is equal to 6. And on the other hand, the value of j, which was initially 5, it was pre-incremented. That means it became 6, and then that value of 6 was in fact printed over here. So that value remains as it is and it gets again printed in this place as well. So here you'd see I is equal to 6, j is equal to 6. So why not we execute this program and see for ourselves if what we expect is in fact what we obtain. So let's compile and run this at one go and see what the result is. It's taking some time. Just we need to be patient. Yeah, here is the answer. So if you just shift this Okay, here a little more. Yeah, so as you can see, at the first instance of printf, I is equal to 5, j is equal to 6, and in the second instance of printf, I is equal to 6, j is equal to 6, just as we had expected. So we have, I hope you have understood the importance of the pre-increment and post-increment operators, which are basically assignment operators, and they are also unary operators. You could easily make simple changes to the program to test the pre-decrement and post-decrement operators as well. You should maybe take this as an assignment and do it yourself. The next category of operators that we would be discussing is the relational operators. Now, these are the different types of relational operators in C. This represents the not equal to operator, this is greater than operator, less than operator, this is greater than equal to operator, and this is a less than equal to operator. So when do these operators come into play? When we are comparing the values of two variables. Suppose you have two integer variables, x and y, and suppose you are assigning the values of 3 and 5 into x and y. Now you can test whether x is greater than y. So you use something called an if statement. We have discussed if statements in another of our audiovisual lectures. So we can have an if condition in this manner, where you are comparing the value of x and y, and you are testing whether x is greater than y. Okay, so I wouldn't like to discuss the details of the if construct right over here. At this moment, it is sufficient to know that these are relational operators used to compare the values of two variables. So as is easily understood that these are binary operators because you have two operands. Now I missed one very important relational operator which is not shown over here. That is the equality operator. So when you place two equality signs one after another, this signifies an equality operator. So suppose you want to test whether two variables, say a and b, are equal or not. So you would use an if construct like this: if a is equal to b. As I said before, the details of the if construct, we'll be discussing it in another tutorial. But the important part is you are comparing, or rather testing, whether two variables have the same values, share the same values or not, using the equality operator. One very important point to note is that students, when they are first learning the C language, have the propensity to make this mistake of confusing the equality operator with this operator. Now, what is this operator? We have already discussed. This is an assignment operator. So when there is only one equality sign, it's an assignment operator. When there are two equality signs one after another, that represents a relational operator, more specifically the equality operator. Now we discuss logical operators. Now in C, there are three logical operators. Logical AND, symbolized by two ampersand symbols. Then you have logical OR, symbolized by two vertical bar symbols or pipeline characters, as some may call them, and finally logical NOT, symbolized by an exclamation symbol. Now these are also known as Boolean operators. The logical AND and logical OR are binary operators, so they have two operands, while the logical NOT is an unary operator because it has only one operand. It operates on a single operand. Now, where do we use these logical operators? When we want to combine expressions containing relational operators, or when we want to combine two or more relational expressions, we would need to use logical operators. Let us recollect when was the first time we were introduced to these Boolean operators, AND, OR, and NOT. If you remember, we were introduced to them for the very first time in our digital electronics class, where AND, OR, NOT were names of basic gates, and the truth tables corresponding to these basic gates are written on the right hand side. For AND gate, when both of the inputs A and B are 1, that means high, both of the inputs are high, then only the output is high. Otherwise, in all other cases, the output is low. So this is the uniqueness of the AND operation. For the OR operation or the OR logic gate, when any of the inputs is 1 for this combination of inputs or for this combination of inputs, or when both of the inputs are 1 for this combination of inputs. So for all these three cases, when one or more of the inputs is 1, that means assume a high value, then the output Y is 1 or high. So this is the significance of the OR gate or the OR operation. And finally, what does the NOT operation say? The NOT operation says that whenever you have an input A, the output would be the complement of A. That means if the input is 0 or low, the output would be 1 or high. If the input is 1 or high, the output would be low or 0. That means the reverse, or the inverted form, or the complement. You can express it in any way. Fine. So to actually implement the logical operators in a C program, we need to take up a particular example. So that's what we are going to do now. Here we have a program already written for you. So have a close look at the program. This is the logical AND operation we are talking about. Here it is used to combine two relational conditions or relational expressions containing relational operators. The first one is A equal to 5. That means it's testing whether A is equal to 5 or not. And the second one is testing whether B is greater than 0. So as we have already discussed, when we write two equality signs one after another, this signifies an equality operator, and this signifies the greater than operator. So these are relational operators. So we had started out with what values of A and B? 5 and 2 respectively. So obviously this condition is satisfied as well as this condition is satisfied. Better we should say this condition and this condition both are satisfied. So in the if statement, we would move over, the control moves over to inside this if statement. That is, it prints that the condition is satisfied. If the condition were not satisfied, then the control would have moved whatever follows the else statement. Now I could have used braces to demarcate the scope of if and else, but since there is only one line for the if condition, and again there is one line following the else condition, you can, or I have omitted. So let's braces. Execute the program braces if the first of all only one line or one statement follows the if or compile it conditions, and execute it. As you can see, the condition is satisfied. This is what is being printed as it should be. Now, what if we put, say, b is equal to 0 over here? Obviously b is equal to 2, it's not equal to 0. Now if we execute this program, so as you can see, the condition is no longer satisfied, so the printf statement inside the else condition is being printed as it should be. So this is the importance of the logical operator AND. Now there are some finer points which need to be discussed when we discuss logical operators. The first is that instead of an expression, a relational expression being an operand on either side of the logical AND operator, you could also have any expression. You could also have the name of a variable, just the variable, and you could even have just the name of a constant, the name of a constant or just a constant. So the operators on either side of logical variables like logical AND, logical operators like logical AND and logical OR can be any expression, any variable, or any constant. So what is happening over here? So what actually goes on? The thing that goes on is the value on, if it's not a Boolean expression like this, because this is a Boolean expression, the result is either true or false. If you had just given the name of a variable, then the value of the variable, if it's non-zero, then it would have been taken as true. And if the value of the variable, or the constant for that matter, equals 0, then it would have meant that the Boolean condition is false. So why not put this into practice, test what I just said. Okay, so let me write over here simply A, and let me write over here simply B. Now what is happening over here? Now since the value of A is 5, which is non-zero, and the value of B is 2, which also is non-zero, that means both the conditions are assumed to be true, and the result of this operation, I'll come to that later. Okay, so this condition is satisfied, so we should have this printed. So let's try it out for ourselves. So we go to execute and compile and run. Fine, the condition is satisfied, okay, as we expected. Now what if the value of B initial value, the value of b is 0. b is initialized to 0. So now the operand to the right of the logical AND operator is 0, which translates to false, the Boolean condition false. So since this condition is satisfied because the value of a is 5, which translates to a non-zero value, which is a non-zero value, that means it translates to the Boolean condition true, but on the right hand side you have a false condition. So since one of the conditions turns out to be false, therefore this condition is not satisfied, and therefore what should be printed is this statement, this string, that is the condition is not satisfied. So let's compile and execute this as well. Yeah, the condition is not satisfied as we had expected. Interestingly, if the value of b is made, say, negative, now what happens, the operand to the right of the logical AND operator is negative. Now negative values translate to true condition. Why? Because any non-zero value is considered true in C. So then, since a is also non-zero being 5, b being also non-zero being -4, both the conditions are satisfied, and so what would be printed is the condition is satisfied. So let's check it out. Yeah, condition is satisfied, just as we expected. Also, instead of using the name of a variable, we could also have used a constant. So instead of writing b, we could have written, say, a constant value 6, a literal, and then since a is non-zero and the constant value 6 is also non-zero, again the condition would be satisfied and we would get, or this printf statement would be printed. So let's again compile and run and check it ourselves. Yeah, condition is satisfied, just as we expected. Next, we will let's make a few changes to this program. First of all, we would comment out this portion. Fine, we are done with the changes. Now have a close look at this part of the program. Now as you can see, the operands on both sides of the logical AND operator, one is b is equal to b minus 1 and one is b is equal to b plus 5. Now in C, when logical and or logical OR operators, the expressions containing these operators are evaluated, the expressions are evaluated from left to right. That means first this expression would be evaluated and then this would be evaluated. Another point to note is when the left hand side expression is evaluated for the logical AND operator, if the condition turns out to be false, then the result of the whole operation doesn't depend anymore on the evaluation of this expression, because one condition is false, then the result of the AND operation will always be false. So the second expression is not at all evaluated. There is no need to evaluate it, so it's not evaluated. So this thing would be more clear if we insert print statements, if we insert, or rather if we use another variable, let's say int C, and assign the result of the logical AND operation, that is the whole result, the output of this logical AND operation, into the C variable. So the C also needs to be printed, so we do that. C is equal to %d and b comma c. Now what's happening? Now let's follow this closely. I'm using the highlighter now. Just a moment. So let's take it one by one. At the top, you see A and B have been initialized to 5 and 2 respectively. Now here we are working with only B, so the value of A is not required. B starts out with 2, value of 2. Now here this expression is evaluated first, so the value of B becomes 1. Now 1 is non-zero. Since 1 is non-zero, therefore when we are using logical AND operation, this translates to a true value, and this expression is also evaluated. So the value of B has now become 1. This value of B is incremented by 5, so the value of B becomes 6. Now since 6 is also non-zero, that translates to being true. The condition, the Boolean result would be true. So both these conditions being true, then the result of the AND operation would also be true, and in effect the value of the result would be 1. That 1 would be assigned to the variable C. So we would expect to see printed B is equal to 6, C is equal to 1 over here. So in a nutshell, what we learned right now is two things. First, that the expressions related to the logical AND operations are evaluated from left to right. So in this case, this is evaluated first, and then this is evaluated second. Next, for logical AND operation, when this expression is evaluated, if it turns out to be false, then this expression is not evaluated. It is skipped. It follows from the truth table of AND gate we had discussed at the outset. So as you can see, this is the truth table of the AND gate. So if in the input combinations there is even one of the inputs is 0, so that means this case or this case the output is always 0, false. So there is no need to evaluate the other input, input condition. Okay, so this is what is important. And finally, another thing to note is that the result of a logical AND operation can be either true or false. When it's true, the actual value of the result is 1, and that gets assigned to the variable c, which is printed. And when it's false, the value of the result is 0, which would be assigned to c and printed. So let's run this program and see if we actually get the result that we expect. That is, we should expect b is equal to 6 in this case and c is equal to 1. Let's compile and run. Wait for the result. Yeah, b is equal to 6 and c is equal to 1, just as we had expected. Now let's make a little change. Here, let's make b is equal to 1 and see what happens. Now when b is equal to 1, then since this is evaluated first, 1 minus 1 is 0, the value of b being 0, and then the operand to the left of the logical AND operation has become 0. That translates to being false. So since for AND operation, if the first operand is false, there is no need to calculate the second expression, and that is what is done internally by C. So this calculation is skipped. Only this calculation is made by C. So the value of b is equal to 0 and 0, and this since this is false, one of the conditions being false, the result of the operation is also false. The result of the logical AND operation is also false. That translates to being 0. So the exact result value is 0. That gets assigned to C. So what we would expect to have printed on the screen is b is equal to 0 and c is equal to 0 as well. So let's check it out. Oops, we did not see any result. The screen was blank. So did we make a mistake? Well, we didn't make any mistake. The condition that turned out to be false ensured that the control did not enter whatever followed the if condition. That means this printf statement could not be accessed. So there should have been an else construct after if, which was not present in the program, so nothing was printed on the screen. So how do we then print the value of b and c for this case? The answer is not very difficult. We can just omit the if statement completely. There is no need for the if statement. Why not remove it? So just evaluate the value of c and then print the value of b and c. So let's execute it again. Oh, we have used an extra parenthesis and forgot to put the semicolon. So now let's execute it again and see for ourselves. Yeah, so finally we got what we were expecting. The value of b is equal to 0 and the value of C is also equal to 0, just as we had expected. Now you can also play around with these examples by testing the logical OR operation or even the logical NOT operation.